Welcome back to Reverse Engineering 101. In episode 1, we set up our VM and tools. Today, we're going to dig into one of the most important concepts you need to understand before you can reverse anything serious: calling conventions. We'll learn how to tell the difference between CDECL, STDCALL, FASTCALL, and even a variadic function and a struct by value function just by looking at the disassembly. To understand the rest of this video, you're going to need a basic grasp of assembly. If you wish to learn but don't know how, you can always subscribe to my Patreon and reach out to me. So what is a calling convention? At the simplest level, it's just a rulebook that says which registers or stack locations hold arguments, how the stack frame is set up and torn down, and who is responsible for cleaning up arguments after a function call. In 32-bit Windows, there are three main conventions: CDECL, which is the default for C and C++. The caller pushes arguments and also cleans them up. STDCALL, which is heavily used in the Windows API. The caller pushes arguments, but the callee cleans them up with a special ret-in instruction. FASTCALL, which tries to be more efficient by passing the first two arguments in registers, ECX and EDX. We'll also look at a CDECL variadic function, because variadics can only be CDECL, and a struct passed by value, which shows how compilers treat small aggregates. Right at the start of main, we see the prologue push EBP, mob EBP, ESP, and ESP whatever numbers. This is the compiler creating a stack frame and aligning the stack for performance reasons. This pattern will repeat in almost every function. Our first test is add CDECL. If we step over the call, we see it just returns 12 in EAX or C. Notice when we return to the caller, there's no ret-in popping arguments because there weren't any arguments. But with CDECL functions that do take arguments, you'll see the caller adjust the stack afterward. That's the big tell. CDECL means the caller cleans up, but there's no cleanup. Now check out the add std call. Look at the decorated name. There's this little @8. That suffix tells us this function takes 8 bytes of arguments, or 2 integers, because it's 32-bit. Step inside and look. It just sets EAX to 2, and here's the key. The return instruction is ret8. That means 8. The function itself pops its arguments off the stack before returning. So in STDCALL, the callee cleans up. That's why the Windows API loved it. It just gave them smaller call sites and less caller code. Next up is add FASTCALL. Look at the decorated name again. On MSVC x86, FASTCALL passes the first 2 integer arguments in ECX and EDX. Let's set a breakpoint and look at registers before we step in. ECX holds 7, EDX holds 5. Inside the function, it's basically going to add the 2 using some moves and return A plus B. So here we can see it takes ECX and EDX and combines the 2. So they're right in the calculation. That's the signature of FASTCALL. Variadic functions are only possible with CDECL. Why? Because only the caller knows how many arguments it pushed. Here, we call some variadic CDECL 4, 1, 2, 3, 4. As you can see, we're pushing the arguments in the caller. So we push 5 values onto the stack, the count plus the arguments. After the call, the caller does add ESP 14 to clean up 20 bytes. Inside the function, you can see the logic. Load the count from EBP plus 8, then loop, adding arguments from the stack one by one, using LEA to step a pointer up, and sub EDX 1 until done. It's basically a textbook variadic, and here's a fun bonus one. Consume struct by value. In our code, we passed a struct with 2 ints, A equals 3 and B equals 9. In the call site, the compiler pushes 9, then pushes 3. Well, it's backwards in this case, but doesn't really make a difference. Inside the callee, EBP plus 8 is A, EBP plus C is B. This is how small structs get passed by value. The compiler just expands them into pushes on the stack. The last helper is write hello, which is STDCALL with no arguments. It calls into the C runtime's fputs to print hello from STDCALL. Notice the decorated name once again, which shows as STDCALL with 0 bytes of arguments. Let's check Ghidra decompile. I'm not going to explain how to use Ghidra. You can watch a tutorial, but I'm just going to be in the main function. And it's quite messy, but if you start renaming functions and variables, it starts to look like the real C++ we wrote. This is why reverse engineering is as much art as science. Tools give you quite weird output sometimes, and you have to change it back into something more readable. If you're subscribed to my Patreon, you can get access to homework, one-on-one calls, and much more. Once you submit, you'll unlock my solution write-up in the Solutions channel. Remember, the goal isn't to copy answers, it's to train your eye until these patterns pop out naturally. That's it for episode 2. In episode 3, we'll look at the PE header itself so you'll know what the loader is doing before your code even runs. See you next week.